Hi, folks. Good afternoon. It's 1:59. We'll start in exactly about a minute. But if you can, just a couple of people wave of hand. If you can let us know if you can hear us and see Ronan in the background there. He's busy drinking coffee.
I know that I can see the
Yes.
screen. I cannot see your camera if you share them.
Yeah, no, no worries. So they can see you. No worries there. Okay, so it's 1:59, and we'll just go through the regular questions. I mean, the presentation that I have to make. So Jim Stephenson, very nice of him to come forward and say yes, he can see you and he can hear me. So good afternoon, good morning, good evening, wherever you are, people. My name is Paresh Motipala. I'm from Boston, and Ronan is from Israel. And he will tell you a little more about himself too. But I just wanted to go through some customary slides that we have to present here. So I'm going to start it like now. So our sponsors are SUSE, and they've been doing this for a long time for us. So please do check out. There is a question already. Yes, we can see him and hear you. Shalom. Somebody saying to you, my friend. Okay, good. Okay, so so April 5 is past his 20th birthday. So we'll make out like a lot of things happening around that time, and I don't know where they're going to have the party, but there's going to be some trivia contest on Twitter. So if you can, please go ahead and tweet about us as much as you can. Tweet about PASS. The PASS submission of papers, I think, is also on. The past 24 hours of PASS session submission is also on. So if you guys want to go and do it, and just show of hands, how many of you are from the Boston area? If you can just possibly raise your hand here, I would love to connect with you guys too. So this is coming up too. I have submitted some of my own sessions. Hope to see you guys there. Um, the PASS Summit, if you use the discount code given below, VGDISKG0E, you can get $150 off on an already low price at this time. So please go ahead and use it. Some of that money that you spend on your registration actually comes back for the betterment of this virtual group too. So I look forward to getting you guys from there. Wait, somebody said not from Boston, but a Red Sox fan. Oh man, that's good for me. Yeah. Oh, come on.
This is a good way to meet neighbors.
Correct. So the reason why I brought up the question of who is from Boston is because we have a Boston SQL Saturday coming up, and we have about seven that they are showing right here. In US and Canada, there's one in Brazil and one in Iceland. Um, Actually, Iceland is this week itself. So there's a lot of learning happening around the globe all the time. So please feel free to go ahead and sign up at any one of them. These are free events. Yes, you can use SQL Pass as a hashtag. The handle is SQL Pass and at Pass Community too. So please do follow them, connect with them, and it'll be one of the best things you would do for your career. Further, we have so many virtual chapters you might really want to join. I have the pleasure of running two of these. One of them I'm here today, and the past professional development is also something that I run. So I would love to see maybe Ronan speak about it at some point in time. So without much ado, let's introduce Ronan. Okay, so Ronan and I actually haven't met in the past, but he's a senior consultant and applications data architect. Okay, he's got 15 plus years experience in a variety of programming languages. Does that mean you're old, Ronan? I don't know. And you can read this. This will be
Know that this is very old. It stayed 15 for more than 5 years, but that's okay.
okay. So that we didn't know.
No, this is my fault. This is what I sent you. It's funny. I just noticed it now. That's okay.
Yes, and please also, next time share the link to your blogs also. We'd love to see your blogs, right? And TechNet articles. That would be awesome. And he is a data platform MVP. So without much ado, I'm going to hand it over to Ronan. Uh, The protocol is if you want to ask any questions, I will be monitoring the questions and any concerns that you might have. Please do so. Ronan, you are a presenter now, my friend, and take it away from here.
Okay, thanks, Bhavesh.
I'll be on mute.
Can you
Yes.
please share the pool? I don't know how we do it. If you
Have a
can
poll.
share
Yes,
the
I have a. Yes, I have it here. Come on, baby, you can do this. Paresh. So, guys, Ronan asked us to kind of run a poll here. All we need is quick answers to these.
I will speak about it if they can see it. I
Yep.
just cannot see it.
Oh, because I made myself as a presenter, or I made you as a presenter. I'll have to make myself as a presenter. Give me a second. I'll do that now.
Oh, I see pool open, something like this.
Share my screen. So I'm just gonna see if people can see that too. Okay, folks, can you see the poll? Please let me know. The show of hands, please. And we would like for you to vote, and we will close the vote as soon as possible. I'm going to say no.
No, I don't see. We can continue without, but it's
Okay.
best to
So
leave
yeah, we
it.
have already 67%
Okay,
say yes.
try
Okay,
to
good.
fix it. In the meantime, I will tell the people what the pool is about,
Hmm.
and we'll continue like this, but try to
Okay.
fix if you can do it. So, good
Also,
day, everyone, and welcome to the SQL Server Internals World. I hope that you can see me. Paros, you can see me, the camera?
no, wait. So you're already the presenter. Go ahead now.
Okay, so there isn't a pool.
Yep. The poll was 2/3 of them say it is important.
Okay, let's leave it.
Can
Let
you
me show
share
you.
your screen now?
1 second. No, I don't see the option. Share here. Okay, I have the
Okay, one sec.
option.
Somebody has a question.
No,
No?
to share. This is always on live. 10 minutes ago it worked. Let's see. No, I don't have it.
You are a presenter, definitely. Connected to audio. I can hear you. So, what is the question here? No one is talking.
Yeah, okay, we are talking, but we don't have a lot of time. So let's
Folks.
see what we can do. No, it's definitely not working.
Okay, I'm going to remove you as a presenter and see if I can add you back, right? I'll make myself as a presenter. Stop sharing my
Okay,
screen and going to make you the presenter again. Okay, so you have to be able to share your screen now. So if you see on the little left side of the control panel there, you should see a screen. There will be like two screens there. There is a microphone button, there is a video camera button.
I see change presenter,
Yep.
but I only see option to put database administrator
Oh, you
virtual.
know what? Maybe let me see if I can put off the poll. Right? That might help. Close the poll, right? Okay. Ah,
Okay, now I can share my screen.
yeah, okay. That makes sense.
Okay, can you
Cool.
see my screen?
Yes, we can see your screen now. Cool. Thank you. Let me see.
Screen, camera, everything working. Okay, so we had a rough start. Once again, good day everyone, and welcome to the SQL Server Internals World. My name is Ronen Arieli. I'm from Israel. I work as a senior consultant in the field of data platforms and developing application, mostly as architect. But one of my greatest passion is diving into the internals and the undocumented information. 1 second. There is a small issue with the camera. Okay. And today's session is all about internals, but I will focus on the practical side of the internals and how we can use the information in order to improve our performance in a daily work. There was no presentation in this session, but only live demo. But before we start, I wanted to put a poll. I understand that it didn't work. I will tell you what it's about. There was a very common question in the forums that I found everywhere, and several weeks ago, it was in the MSDN again. The question is the order of columns important? Now, I wanted to get your answer since we
Hey,
cannot.
Ronan, can you
Yes,
do think? Can their voice is coming very choppy from across the world? So you may want to
yes.
turn off your webcam actually.
I need what?
You can turn off your webcam. That will be great help. It'll conserve a lot of bandwidth. So we don't need the webcam.
Welcome, it's important, but okay, people can see the screen. Okay,
Yeah,
so no
it
camera.
will conserve a lot of bandwidth. Okay, thank you. Go ahead.
Okay, so the poll did not work, but basically I wanted to.
No, the poll did work. The poll did work.
Oh, it worked? Do you have
Yes.
numbers?
Yes. So two-thirds of the people said it is important. One-third of the people said it is not important.
Okay, so before you voted, I wanted to give you some information which might lead you to one direction. The information was that I don't want to get answer as developers. I am only looking for the answer as DBA, meaning something like performance or errors or something like this. And the question is, can the order impact those issues? I understand that most of you say that you think it is. Let me give you some of the quotes that I found online. And this is from the top contributor online. I'm talking about people that are Microsoft MVP. There is someone that have more than 500,000 reputation at Stack Overflow. Several of the top contributors, and this is the information that they answer on the forums. For example, the columns order is just a cosmetic for the human to use. Another quote, you should never use insert without explicitly specifying your column anyway, so it's not important. A columns order is not a concept that's relevant to the SQL table. Another one, no, it doesn't matter. You can always retrieve the columns in the order you want by specify the column explicitly in the select. And the last one that I will bring today, it's saying, well, not for SQL. Performance and functionality will be exactly the same. Now, those people, I understood that the question was not related to the order of column in the client side. I'm not sure how you saw it, but let's see in practical if order is important or not for the DBA. I have a small script I want to do, but first of all, let's create this. Okay, can you see my screen, the SSMS?
We can,
Parash?
yeah.
Great. So let's copy, let's paste. And this is a small script that I will execute right now. And voila, I'm getting error. Now, if you are familiar with this type of error, I will give you a small hint. I don't want to show you the script at this time. This error, for example, raise when we create a table and we try to add another column, but the table structure already use all the size of a page, 8 kilobyte. So it say, hey, you cannot use 11,000 kilobyte. It's not a fit. I want to show you what I'm doing. I only changed the order of column. I haven't done anything. This is the same file. It's live. And now I will execute it. And everything is working. So definitely order is important for errors and for size. I will go to this script at the end of the meeting once we will have more information and we will understand what exactly is happening here behind the skin. So let's start. At this time, I want to explain what is logical layer and physical layer. SQL Server is a complex application which is a closed code. As such, it uses internal code, internal element, which developed for the use of the SQL Server itself, not for the end user, not for us. Obviously, there is no official documentation about those elements. Behind the skin, SQL Server use those elements to provide the end user what I call a logical layer. For example, I will create a small table. And now I can work with a logical layer. So we can select from the table, we can select from the table, we can even check what we have in the sys columns, and we can use the Explorer and everything that we use on daily basis. But we are not using what really SQL Server have behind the skin. We are using the logical layer. In order to explore the internals of the SQL Server, we must use several undocumented elements. For the sake of this lecture, I will create a new function just to make our life easier. Don't care about the code right now. I will upload everything online. So just let execute it. And let's see what happened when I use it. It is important to mention, for example, that those are undocumented elements. And this is the most important screen that I can give you for today, because here I can see the real physical structure of the columns behind the skin. Let's go over what we see here. So object ID, this is the table ID, index ID, partition numbers, leaf null bit. This is the physical order of the columns, not what the user see. Columns name, partition columns ID, this is the order that the user see. This is the logical order. Max length total. You know what why we have both of those. We have some types that are not inline. For example, nvarchar max can store the data outside the row. And we have key ordinal. This say if we have a key. Let's create a key. It's a good starting point. Now check. Every time I will check what we have in the table, what is that structure before, I will do something and I will check what is the structure after. So now I add the primary key and let's compare what happened. You can notice that the only change is this. The key ordinal got the value 1. Next, we have the leaf offset. This is the most important, but in order to understand this, I will move and show you one screen from a different lecture that I have. Let me find it here. I don't even start the presentation, only show you this. For today, we only need to know 2 points. One is that SQL Server stores all the fixed size column together here, one after the other. The value of the leaf offset that we see is the real position of the column in this order in bytes. Next, we need to know that all the variable columns are stored in a different place in row, and the leaf offset that used for them is always negative, and it only gives us the order of them. So now we can come back here and we see our first column is int 01, start at byte 4. This is the real position on the disk. And the length of it is 4. This means that the next column will be at position 8, but the next fixed size. This one is a variable. So this is in a different position. At this time, we are not looking at this, and we see, yes, the next fixed is at position 8, and 8 length, and the next one is at 18. So this is the most important to understand if something was changed in the order of column in the disk, not related to what the user see. Okay. Let's examine some binary data. It will help us to understand this better. Again, this is more undocumented element. First of all, I check where are really the pages of this table. Okay, I see that the page that include the data is here. So now I can check what is the content of the page. One second. There is a small bug in the SMS. And okay. Okay, this is the data behind the skin. And what I want to go is to the real data. What we have here, this is the binary data on the disk. What we have here is the implementation as a text. This tool just present it, and we see this is the data that we have in the row that we added. Remember that I inserted first Ronen and then Arieli. When we will change the order, we might see here different information. Okay, so let's see what happened if I drop the primary key. Dropping the primary key, we don't see any change except again this one. But what about clustered index? We know that cluster index is something else altogether. So let's create now a cluster index. And check this out. Suddenly, we have another column here. This is the after. What is this column? This is a physical column. It exists in the disk, but the user do not see it. We only see the logical columns. And this is very important to understand. And now let's see what happened to the order. See, column int 01 used to be in position 4 byte. Where it is now, it moved to position 14. Why? Because the cluster index was using a column int 0, 4. And this means that it moves this column to the first place in the disk. This, of course, needs to be done on all the rows that we have in the table. So creating index, cluster index, it's very dramatically. Another row added, the logical position stayed the same. You can see the logical is still the same, but the physical change. What about the data? What happened to the data when I created all this information? Let's examine the data that we have. Okay, so again, let's see where is the page. Oops. Check this out. The order changed. It was Ronen Arieli, and now we have Arieli Ronen. The data in the disk is totally different. So if you know to read the disk, the binary, we can even do more stuff. What about non-cluster index? Okay, first of all, I added this primary key. We removed it before. And now we can notice that we have something very interesting. We have 3 new physical columns that were added to the table. This was added for the index, the non-cluster index. And what we have inside those columns, first of all, in one of them, we have the value of the clustered index. And the other two include the clustered data and the uniquify column. So we will always have those two, and according to the included column, we will have more columns, physical columns. What happened if we rebuild the index but online? At this time, we have, by the way, remember 8 rows in this table, meaning 8 physical columns. Okay, so when we rebuild index online, what happened is that we got another row in the table. And this column that was added has a value of is antimatter 1. Let's find it here. This was the one that added now. This parameter is used only during the build phase, and it will be cleared at the end of the index build. It's used for internal work to make sure that the data is consistent. Let's do another small task to see how it implement, how it impact, sorry. What I'm doing now, I enable change tracking, and I will see what we get. Oh, now we have 10 physical columns. So enabling change tracking on our table added another hidden column. This was the starting for this lecture, but I want to go over a common question in the forum. And I want to present you another scenario. This is a question from the forum. We have a table which include integer column, but the company don't need this column anymore, and the user came to the forum and asked, what can I do? What is the best way to work with the table right now in order to reclaim the size or simply improve the performance? And this is the answer that he got. If I summarize everything, there were 4 ideas of what you should do. The first one is probably the most common and the first thing that anyone will think. Let's drop the column. If we dropped it, so that's it. It will not be exist anymore. The second one is to update the value to 0. The third one is to change the column into null. It was not null before. And another option was to alter the column type, for example, smaller type. Let's examine those ideas and we'll see if they are actually give us something and which one is the best. So for the sake of this, let's create a new table with 1 row. Great. And now let's try solution 1. I drop the column. This make the most sense. Check what happened. The column was dropped, but only logically. There is nothing that changed on the disk. All the position of the other columns, including this one, are the same. Nothing was done, but only on the metadata, and this is why this action is very fast. This, by the way, reminds me a story, a real case story. I got a support call from a client. The DBA contacted me and said that someone in the company dropped a column in a table by mistake. By the way, it's always not you, it's someone, you don't know who. Anyhow, the DBA explained that they do not have any backup of the database, and they basically lost all the data. According to Microsoft documentation, at that time, it said that this action cannot be undone. But is this true? Did we really lost the data? Well, the answer is that the official documentation is simply wrong. The simple user, the one that only use the logical layer, don't have anything to do. But if we have the knowledge about the internals, we can do a lot and we can restore everything, as I will show you right now. But first of all, my action was to go to the documentation and fix it. So this is the documentation somewhere here. And this is basically why you see my name here. Now it's okay, the documentation is perfectly at this time. So let's examine the data that we have, the binary data on the disk. All the data is here. Nothing was lost. As I told you, dropping the column does not change anything. This means that we can restore the data. How? It's a different lecture. But all the data is in the disk. Don't worry, you didn't lose anything. The conclusion is that we did not reclaim any space from the disk, and drop column by itself is not any solution for the question. So let's go to option number 2. Option number 2 was to update the value to 0. This, I don't need even to execute any test. It makes no sense. The column was big int. This is a fixed size type. It means that it's not matter if the value will be 0 or the value will be 1 million. It will always use the same size. In our table, 8 bytes. Okay, so this is not a good solution. Another solution which people put in the forum is this. Let's alter the column from not null to null. Well, it makes sense maybe. Let's create a new table, the same table, and let's alter the column to be null. Execute. We can notice that nothing was changed. The only thing that changed is the value of is nullable, but all the positions are the same. This didn't help us in anything. What about the opposite side? This is not related to the question, but for the sake of the meeting, let's go over and see what happened if we move from null to not null. At this time, something happened behind the skin in the physical structure. You can notice that another physical column was added, but no change was made in the data or in the position. The position of the hidden column is the same like the position that was before, so we don't see any different. But we have another column behind the skin. Solution 4 was change the type of the column to a smaller type. Okay? Makes sense. Actually, except solution 2, everything makes sense in first glance. Let's try now to change the column. It was big int. I change it to tiny int. It's a big difference. Execute. And what happened? We now have another column behind the skin. Not just that we did not reclaim the space, we actually use more space. Another physical column was added, no change in the physical position, and the action was in place. It means that if you check the old one and the new one, you will see that this is in the same position. Okay, for the sake of the meeting, again, let's check the opposite direction, not related to the question. Just what happened if I will go and take a type and convert it to a bigger type. So now we have tiny int. I will go back to use big int. Execute. Oh, just remember, we are now 6 physical columns. And now we have 7. Behind the skin, the table become more and more complex. It's not simple, and it can cause a lot of performance issue once it became more complex. Okay, so what happened here? This action is basically equivalent to drop the column and add a new column. Even when we have a place in the structure, because we are using the same size as the original size, SQL Server don't put it in this space. It add it to the end. Check the position. The column that was added, the new one, is actually at position now 52 byte, and it end at byte 60. Our table become bigger and bigger. And all this you do not see when you do not work with the undocumented information. You think that, hey, this is the same table, small table. Why the database do not work? Why the query becomes so slow? Okay, let's continue. By the way, there is option to add a fixed size column in place, in the place of the old one. And this is only if we dropped the column that was the last one in the order. You see the last one here now. Let's see what is the physical position. The last one here is this one. I drop this one and then I add another one. In this case, it's in place. We didn't make the table bigger. We did add another physical column behind the skin, but we didn't make the table bigger. Okay, so what is the solution for the question in the forum? For this, I actually recommend you to go to the original thread. I will give you the link. One second. If I have it right now. Okay. Sorry for the delay. Here. Actually, I will put everything online again, but if you want, I have it open here. This is a question about order of columns, and you can see all the discussion. I recommend to go over it. There are a lot of mistakes here, but we are focusing on what's important and what gives us good information. Moving forward, how can we fix all this nonsense? How can we clear all this? So there's one thing that you must remember, and this is that we can do it using the simple rebuild to the table. And it's very important. Let's execute it. You see all this information that we have in the upper result set, and down there it's all clean. The conclusion is very simple. If you do a lot of tasks on the DDL, you change the table, you add column, remove column, or other element, including indexes we saw, then remember to clean the physical structure using rebuild. And rebuild can take time and the resources because this is a physical change. How are we with the time? Wait. Okay, so we're back here. Let's put some more information. Some more playing. We'll create another table. Plus this. Execute. And now let's examine what happened. This is a different table. I want to examine what happened when I take a fixed length and change it to a variable length. By the way, maybe you have an answer. What do you think will happen to the column? If you remember, I mentioned something in the beginning. What is the difference between fixed and variable in the row itself? So if you can write it in the chat, and Parash can tell me, maybe you have a solution for this before I execute. So I'll give you 5 seconds. 4, 3, 2, 1. Parash, do we have any idea? Parash, can you hear me?
It takes me some time to unmute. So
Yeah, that's okay. Can you
no
check?
questions yet. It's almost 15 more minutes to go, but I just wanted to share that, yes, we can hear you all clear.
Okay, can you check if there is an answer to the question? Can someone say what happened to the data or to the column behind the skin when we move from fixed size column to a variable column? If there isn't anything until now, so let's see how it works. Execute. And I will explain it very simple. The column physically moved. There wasn't any other option because if you remember, I mentioned in the beginning that all the fixed size column are in one place and the variable columns are actually in a different place in the row. So when we are changing between them, it must move between those places. Remember that this is a very critical action on the database. It's physical moving data. Okay, let's see the opposite side. What we see now, let's change the size.
This was very unique. I had never seen anything like this in so much detail before. Thank you.
Yeah, this is what interesting about the internal. It's stuff that you simply do not think about them in your daily work, but they are a number one impact of what we are doing. It's simply that no one, not no one, but most of the people do not know about it, and other people that know about it don't think about it on a daily work, but we should. Everything that we do, you need to know what happened behind the skin if you really want to get performance right. I'm going to change the size. This is very interesting case. You remember that when I changed the fixed column, it actually did a drop and create another one in a different place at the end. This is how we got the value 52, if you remember. Let's happen what happened when we are working with variable lengths. So again, I alter the table and alter the column and change it to 100. It was 20 before. Okay, we need to see more of the result. This is what's important. And what we check is this. You can notice that nothing was changed. Even so that we changed the size to a bigger size, nothing changed physically in the table. This is exactly the opposite of what we got when we work with the fixed size columns. Let's do the opposite now. Let's decrease the size.
Hey, Ronan, before you proceed, there is a question.
Yes.
Carmen Johnson is asking, so the solution to reclaim storage after all these invisible changes is to rebuild the index. Is that correct?
Rebuild the table, rebuild the index, yes. Basically,
Okay.
rebuild the table. This will lead all the rest.
Carmen, can you just acknowledge this, please?
Actually, the solution is a combination. This is why I told you, go read the thread. I wrote there a lot of information, and you should read the mistake as well because you can learn from mistake a lot. And it's not really a mistake. It's people that probably know all this. It's just that at the moment they did not think about the internals. So go to the thread. But in short, you must clean all those nonsense, all those physical columns which are not in use, and this is you do using the rebuild of the table. But the real solution is first of all, for example, drop the column and then rebuild the table. This is one solution that will work. Another solution that will work is change the type and then rebuild. So everything is about rebuild in order to actually make the physical change. Okay, did I execute this or not? I don't remember. Let's see, we have 5. So let's execute. Okay. This is the opposite side. Now I took a variable column and I make it smaller. But when I make it smaller, we have a new physical column. This is exactly the opposite of what we have with fixed size. So you should remember this behavior. And another example that I want to show you before we continue, drop and add. You remember that when I did drop and add in the fixed size column, it actually create another one at the end, drop and add with a variable column. Okay, I created a table, and now let's do the task. One second, I need to copy it. Okay, so I drop this column and I add this column. And this is what happened. You can see that we have a new column, physical column that created for us. And the position is the same as before, except that we have this one. Okay. We dropped the column. You remember that we have data there. I put some data in one column. I put Ronen, and in another I put Arieli, and I dropped one of them. Let's examine what we have. First of all, where do you hide? Here. Oops. I dropped the column. It doesn't exist, and again, now it's not here. It's all behave differently when we are working with a fixed and non-fixed. So we actually create something else. We have time for one more example. Let's show what happened regarding partition table. Okay, I create a partition function, I create a partition schema, and then I create a simple table. Let's do it. Awesome. Now let's check the structure behind the skin. This is what we have. Notice what we have here in the partition. We have two partition number. It makes sense. We have two partitions because we split the data into two. And basically, you can see that behind the skin, this is exactly like having two identical tables, but logically, we are using it as one table. So if you compare this one to the one above, it's basically the same. And moving to the most important query of today. Any question? Parash, can you check if there are questions before we move to the summarize? Parash, do you have any question?
Yes, somebody just brought up a question. Okay, give me one sec. Is there no difference in query performance or memory allocation when initially designing the tables with varchar 20 as against varchar n? And then
I'm not sure if I understood what I I understood, or what I think I understood is, do we have any safety against using the memory because all of this stuff behind the skin? The answer is that when we are talking about memory, this is something else because all those physical hidden columns do not need to come to the memory. In the memory, we need only the data. So it's not exactly relevant.
Okay.
So the answer is there is no need for safety. There is need for safety for the query themselves because we change the table in a lot of cases, the physical table, but this is part of the internals. Something we have to manage the table some way, in some way. So this is the way that SQL Server works. Okay,
Yes, and
we are
then one more. Yeah, so sorry, there are 5 more minutes to go, and there are two more questions. So
yes.
one I can take, the other one you need to take. So how were the leaf offsets negative? That is from Sam.
Again, sorry, I didn't hear well.
Amish is asking, how was the leaf offsets negative?
I spoke about it. I will remind you.
Okay.
The
You must have zoned
fixed,
out.
I explained it here. The fixed size columns are come in one place behind the skin. This is a totally different internal lecture that I have about the structure of the rows, but I can use this slide to show it. So all the fixed size column always come in one place here, one after the other, and they
Beautiful.
have a value positive, which give us what is the position from the start. So the start will be like 4 byte. If the first column was integer, then the next column will be at 8. This is only for the fixed. Now regarding the negative, all the variable length column come in a separate place in the row physically. If you open the file, the binary, you will find them a bit different inside the row, but not in the same place, and they have different order. This is the negative value. So the negative value give us the order of the variable type columns, like varchar, and varchar, and etc. Okay?
Okay, so there's one more that saying if this recording is available, yes, this will be available on the same website where you registered. We just have to upload it to YouTube. And Ed is asking a question from the earlier, it's a continuation. What he's saying is when you perform a select star from T1 into T2 statement, will the column allocations be reorganized? It's an excellent question. So
Uh,
you're taking from one table
and,
and putting it into it's like rebuilding the table really, right?
again, what was the question, or did you answer
So
it?
the
I was
question, yeah,
I
no
was
problem.
drinking. It was more important for a second.
Okay, so in other words, is there a reason? Oh, sorry. When you perform a select star from T1 into
You
T2,
should never use. I didn't mention it because we didn't have time. But when this lecture come in 2 hours, this is one of the first thing that I said when I asked is order important. You should never use select star. It hides inside it a lot of issues. So my answer is I don't want to listen to the question. The answer is don't use it. But I will listen to the question. What was the following question? I just stopped when I heard select star. It's like, oh,
so
this is forbidden.
so when you do that, will the column allocations be reorganized? Is the question.
No, select star will use the logical order. So let's go back to one of the
No, no,
examples.
no, no, no. Hang in, hang in. What he's saying is that when you select this logical, okay, select star from T1 and put it into a table T2, will the column allocations be reorganized? Is the question. So
Yeah,
you
if you put it in a
see,
new table, this
it's
is
like
not
rebuilding
relevant.
the table, right? Exactly. Okay.
Yeah, this is creating a new table. This is not relevant to what you had. Again, I mentioned it when we spoke about memory. When
Mhm.
you use the data, SQL Server always take it to memory first. And when you
Okay.
copy it to another table, it copied the data that you read. It's not important what was the physical structure behind the skin. Not important for the future, for the new table. Okay,
Cool.
so before we end, we don't have more time, but to go back to the first question that I showed you that order is important, and this is the script that I use. Now we have the tools to understand what was my trick. So this is the script. As you remember, when I execute it like this, execute, we got an error. And when I change the order of columns, everything worked okay. Now we can go over the script and explain what we did and why this behaved like this. So I created a table, simple table with two columns which are fixed size. Now what I did, very simple, I dropped one of the columns, but this is important, that if I will change this size, then I will drop the one that is at the last place. And this is the point here. When calls one is last one, then drop calls one means that I will be able to reuse this place. But when this order is different and it's going like this, then dropping call one means that I cannot use this place again. And when I recreate the column, it will add more data. And this is why we got an error. Because when I try to add another column, after I dropped the one before, it couldn't because we already used all the place. We used 8,000 bytes. And this is the reason for the error. So yes, error can be related to order. And here I insert one value and alter the table and add another course. This is the one that I actually raised the error. So this is basically all the trick, and this is the link to the original question, which I quoted. And we can move to
So we,
summarize.
hey, Ronan, it's 3:01 already.
Yeah,
So
we finish, we
quick thing.
summarize with three conclusion. You should understand that what we have in the internal is very important for the external. This is the most important point for this meeting. The second one, you should remember that as example, we used the question and we saw that order of the column is important and can impact performance and error. And next, you need to remember that dropping the column does not reclaim any size, and you do not lose the data at this point yet. And with this, we can end with this query and actually say thank you all for joining the meeting. You have my information here, and you are welcome to contact me online if you have more questions. I hope that this meeting was useful for you.
Cool.
So thank you.
Thank you, folks. Have an awesome rest of the day wherever you are. And we will see you in the next session coming up in about 3 weeks. Okay. Take care, guys. Thank you, Ronan. That was really awesome, man. Okay.
Thank you. Before you close, can you copy all the questions of the people? Because after you
Yes.
close them,
So the questions are automatically copied over.
okay, so you have a copy of all the questions?
Yes. So when we record this, right, this will become a part of the questions.
Okay. So
Okay.
thank you all. Thank you, Parash, and goodbye.
Yes, sir. See you soon. Take care. Bye.